My name is Jesse, and if you guys are watching this video, it's probably because you're trying to learn about solar. And just like you guys, I was also on YouTube trying to learn about solar. And YouTube is a great place to start, but where I got hung up sometimes was when I would watch a lot of these videos, there's certain terms and vocabulary that if you don't know what they mean, it's hard to follow along and comprehend and kind of make sense of what's going on in the video. So that's kind of what we're going to talk about, just some basic terminology, some of the vocabulary that's used in solar, and then also just kind of briefly talk about the solar systems that I personally have the most experience with and what I like working with. The way I learned was, aside from YouTube, was a couple books on Audible. I just typed in solar on Audible, and there was like 2 or 3 books. I downloaded them, and they're okay. There's nothing special about those books, but they do talk a lot about the vocabulary, and they stress the importance of knowing the terminology, so that way when you read a diagram, when you read a spec sheet, you're familiar with the vocabulary, you're familiar with the terminology, and you know what all that stuff means. So the I guess more old school, I don't know if that's the right word, or traditional type of solar systems, you would usually have a solar kind of charge controller, and that's going to have like your MPPT or MPPTs in there, and then from there you would have another kind of separate device, an inverter, and so your charge controller would be hooked up to your inverter, and then your inverter converts your DC power to AC power, and then somewhere in there you also have a battery that's hooked up. And so that's more of like a, I hate to say old school, but I don't know any other word for a more traditional type of solar system. That's not the solar that I'm familiar with. The solar that I'm familiar with is the all-in-one inverters. So all that stuff that I just said, the charge controller, MPPTs, inverters, the fuses and disconnects that you would normally use, all that stuff now, in most of the all-in-one inverters, they're all prepackaged into one box. And that's kind of what makes solar a lot more easy to kind of get into, is because a lot of these manufacturers have taken the guesswork out and they've simplified it so much to the point where it's almost plug and play. If you can read a diagram, if you can, match red to red and black to black, you can hook something like this up, and it's pretty easy. You do have to do some reading, some kind of have to have an understanding of electrical and solar, but it's not as complicated as people think it is. With just a little bit of time, you can get the basics down, and you can start with a really small system, and then over time, kind of as you learn more, you can kind of grow with your systems more. So we'll talk more a little bit about inverters later, but this is kind of the type of inverter or the type of solar that I'm very familiar with, and it's not because it's anything special, it's because it's the easiest. This is by far going to be one of the easiest ways to get started with solar, and that's because you basically do the very final connections. This has taken all the guesswork out of it, especially EG4 products. They're super easy to work with, very DIY friendly, and there's tons and tons of resources, forums and videos and YouTube videos on people installing EG4, and they're not like solar installers. They're not like electricians. They're just like a regular person who works a 9 to 5 in an office. And so that's the beauty of a lot of these new systems now, is it's getting very easy, and I feel like that's the new trend now, is to make it plug and play, universally, like easily adaptable. Everything is I feel like moving in this direction. But we'll briefly touch on solar panels. I'll try to make another video on just inverters, maybe another one on batteries. But for the solar panels, I'm just going to highlight, there's a ton of information. This is a spec sheet off the Aptos 440W bifacial panels that I have. There's a lot of information on here, but I'm just going to cover the kind of key points that I look at. I have 10 of these in my backyard. They're hooked up in series, and I'll try and just briefly talk about different ways you can hook up solar panels. I'm going to give the very introductory basics version, but you can make solar as complex as you want it to. You can also make it very simple, and I'm going to go over the very simple and the very easy. So a couple of things that I look at when I look at this spec sheet. Every solar kind of panel that's sold usually has a spec sheet you can download. And if you're buying something used, you're probably not gonna have a spec sheet, but if you turn the solar panel on the back side of it, there's usually gonna be like a little plate or a little sticker or somewhere on there, and it's gonna tell you all the electrical specifications, and that's kind of what we're gonna go over today. And so the first one on this one that I am gonna point out is the 440 watts output. These are bifacial panels, but unless you're installing them on like a pergola or some sort of a ground mount where there's lots of light coming from the ground, you're probably not going to get more than 440. If you're installing them like on a roof or a shed or something, you're only going to get the gain from the front side. You're not going to really get the gain from the back side. Because all the bifacial gain, you can get, I think you can get like up to 10% more gain. So you could probably get maybe 500 watts if you had these solar panels kind of mounted high up, where you're getting the sun hitting it from the front, but you're also getting light from the ground reflecting the back side of the solar panel, and it's going to give you the extra gain. And I feel like most solar panels now, they're all bifacials, or at least that's the direction that when I'm looking at solar panels, it seems like you're seeing less and less of the monofacial panels, and you're seeing more and more of these bifacial panels. So all these figures here on the electrical specification, they get these values like in a laboratory where they have like ideal conditions, the lights hitting the solar panel at the perfect angle, the temperatures perfectly at 77 degrees. And so I don't want to get hung up on temperature too much, but just know that the warmer the temperature is, the less efficient the panels are, and the colder the temperature is, the more efficient the panels can be. So your voltage can rise in colder temperatures, and in warmer temperatures, the voltage will decrease. But again, I don't want to get hung up too much because I just kind of want to go over the basics. And so the first one that's kind of important to know is the voltage open circuit. And so for this solar panel, it is 41.51 volts. 41.51 volts. And this number here is just telling us that the maximum amount of voltage that this solar panel is going to produce with the perfect angle towards the sun at 77 degrees Fahrenheit is 41.51 volts. But that's with no load hooked up to it. That's with it not being hooked up to an inverter. It's not running anything. That's just the max it can output with no load attached to the solar panel. The next one I think is important is the VMP. So the VMP is what the solar panel is going to produce when it's actually hooked up to a load. That's the maximum power that solar panel can produce when it's actually hooked up to a load. And this one is 34.71. And then we will look at, so this is for voltage, and then there's also a similar set of terms and numbers for amperage. And so we're going to look at ISC, and then we're also going to look at IMP. And the ISC is 12.88. This is volts, this is amps. And the IMP is 12.68 amps. Let's find out exactly what ISC means and what IMP means. And I'm just gonna literally ask ChatGPT what that means, ISC and IMP. So ISC stands for short circuit current, and IMP stands for current at maximum power. So short circuit current and current at maximum power. And similar to the VOC, this is the max amount of amperage that this solar panel is going to produce when it's not under load. And then when it is under load, it's 12.68 amps. And so I think another kind of key point here is this equation, volts times amps equals watts. And so I'll talk more about this equation later, but just know that you'll probably end up using this equation a lot. And if you ever watch anybody on YouTube and they have the volts and the amps and they're trying to calculate the watts, they're using this equation. So we've established that the VOC is the max amount of voltage that the solar panel can produce when it's just kind of laying out in the sun, not hooked up to anything. The VMP is the maximum amount of voltage the solar panel is going to produce when it's actually hooked up to a load. And then the same is going to go for the ISC and IMP. That just refers to the amperage when it's just laying out in the sun. And then the IMP is the amperage, the max amount of amperage when it's actually hooked up to a load. And so let's see here. So let's see where they get this 440 watt panel based off of these numbers here. So let's see. I'm going to do the 34.71 times 12.68, 440. So that's how they get this number. They do the VMP and the IMP. And so when I did the volts, I did 34.71 times the amps, 12.68, and I just multiplied those, I got 440. And this is watts. So this is volts, amps. So this is where this number comes from. It comes from the max amount of voltage that this solar panel produces while it's under load, and it's the max amount of amperage that this solar panel produces when it's under load, under ideal testing conditions with the perfect angle towards the sun at the perfect temperature. But what you'll realize is when you actually install these, I don't ever, unless it's like a perfect day where it's like very cold and there's a good amount of sun, I rarely ever get 440. I probably get closer to 390, 380. That's more realistic, at least with my setup. Again, if you have like the perfect angle and the weather's just 50 degrees cold outside, 40 degrees, you'll probably get 440, maybe even more. But just know that when you actually start hooking stuff up, you're probably not going to get 440. So don't be disappointed. I learned that out the hard way. I hooked up my system and I was getting like maybe 65-70% efficiency from the panels, and that's because it was wintertime. And this is another good point to kind of bring up. Depending on where you live, if you live in the northern hemisphere, you're going to always want to have your panels south facing. And in the summertime, the solar panel angle is much better when it's almost flat horizontal. And in the wintertime, the sun comes at a different angle, so your panels are much better off at a higher angle. So in the summertime, you're going to notice that if your panels are mounted, like my solar panels are mounted on a shed, and the shed is kind of flat. So in the wintertime, I don't really get good efficiency because the wintertime, the angle that you want to have is kind of like 45 degrees, maybe more. But my solar panels are just in a fixed position all the time. And so during summertime, they do really well because the sun is almost like directly overhead. And it's perfect to give you the perfect angle to hit the solar panels to make power. But in the wintertime, the sun is coming at like this type of angle. And so your panels are just not as efficient. Whereas if you were to give yourself a better angle, well, now the sun is hitting at a more direct angle, and so the panels become more efficient. Those are kind of key things that are important to solar panels. Is the VOC, the VMP, ISC, and IMP. We kind of touched a little bit about what they mean, and then this equation is going to be very helpful, so familiarize yourself with that. And it's going to be helpful because I'll give you on my own example, I hooked up 10 of these panels in series. And a good way to test if your connections are all working is at the end of one of your, actually this actually is a perfect way to move on to our next topic, and that's how you connect solar panels. So there's lots of different ways you can do this. I'm going to just go over the very kind of basics. And the first one is a series connection. And in a series connection, you're going to have, we're just going to do an example of 3 solar panels. But we'll pretend it's these Aptos. So we got 3 of these Aptos. Each solar panel is going to have a lead, a wire coming out of the backside, and one wire is going to have a positive terminal. The other wire is going to have a negative terminal. And every solar panel is going to be just like that. And so when you hook panels up in series, what you're doing is you're hooking the positive lead from here to the negative lead on this solar panel. And then you're doing the same thing here. You're hooking up the positive to the negative there. And so at the end of your string, you're going to have one negative and you're going to have one positive. And we've established that these Aptos bifacial panels have a voltage open circuit of 41.51. And so these solar panels, we're just going to pretend that they're sitting out in the sun. They're not hooked up to anything. So in theory, we should have 41.51 for each one of these. And so when you hook up solar panels in series, the voltage, we'll say the voltage adds up, but the amperage stays the same. That's with the series connection. And so if we establish that our voltage open circuit is 41.51, so this solar panel is producing 41.51 volts, this solar panel is producing 41.51 volts, and this solar panel is producing 45.51 volts. If we hook them up all in a series connection, our voltages are all going to add up and our amperages are going to stay the same. So we should see 41.51 times 3, which is like 120 or something. 41.5 times 3, 124 volts. So 124 volts. It's actually 124.5 volts, but we're just going to round 124 volts. And so when you're hooking up your system, you're hooking up all your solar panels, you can use a voltmeter. I don't have my voltmeter here. Oh yeah, I do, right here. So here's my voltmeter, and I recommend getting a good voltmeter. Especially one that has the DC capability, because some voltmeters only measure alternating current and some voltmeters can do both. So we're going to hook up our positive lead here to the end of one of the solar panel terminals. We're going to hook up our negative lead here to this terminal, and then our voltmeter should read around 124 volts. It's probably not going to be exactly 124 volts. Again, unless you have the perfect angle towards the sun, it's the perfect temperature, but you should get, somewhere around 100 volts. If you're only reading, 30 volts, that means there's something wrong. Either one of your solar panels is busted, or there's a connection that's not right, or something's backwards. But that's something you can troubleshoot yourself because you know what's going on. And so if I hook up the voltmeter and I'm reading 105 volts, then I can pretty safely assume that all my solar panels are working and the connections are right. And so some of these voltmeters, you can measure the amperage, but they only go up to like 10 amps or 20 amps. Some voltmeters go a little higher, where you can just plug in your leads here and you can get a reading of what the amperage is. But again, only certain voltmeters will do that. I don't know exactly what this one, if this one can go. I know the last time I checked, I think this one went up to like 10 amps, but there's other ones that go up to 20 amps. And if I hook up this voltmeter to switch this to amps, and I hook up my leads there, and it was capable of reading up to, let's just say, 20 amps, then I should also see that my amperage is somewhere around here. Again, it might not be 100% those numbers because it's not at the perfect angle and with the perfect, you know, temperature. But as long as you're close, you can safely assume that your connections and your panels are in good working order. And I'm trying to think of, oh yeah, so that's kind of our series connection here. Most of your solar panels, I would say you're probably going to be hooking up in series. Certain scenarios you're going to hook up in parallel, but we'll talk about the parallel next. Parallel. I think that's how you spell parallel. So we're going to draw our same 3 solar panels. And each panel is going to have its own positive, negative, positive, negative, positive. And so when you hook up in parallel, you're not hooking the positive to the negative of the next panel and going that way. That's the series. What you're doing is hooking up all the positives and you're hooking up all the negatives. So in this scenario, we would hook up this positive lead from this solar panel to that positive lead of that solar panel, to that positive lead of that solar panel, and then I'll be left with one positive lead on that side. And I would do the same thing here. This negative goes to that solar panel, that negative goes to that one, and at the end of my string, I'm left with one negative and one positive. And so the voltages and amperages kind of do the reverse of the series. So in a series connection, the voltage adds up, but the amperage stays the same. In a parallel, the voltage now is the same, but the amperage adds. And so if our voltage is 41.51 volts, and we have them hooked up in parallel, our volts is going to remain the same. When I put these leads here to test my string, it's going to show that my voltage should be around 41.5 volts. And so what's going to be different is the amperage is now going to be changing. The amperage is now going to add up. So we're going to say it's 12.88 times 3, 12.88 times 3. And we get 38 amps is 38 amps. And so that's the difference. When you hook up solar panels in parallel versus series, is the series connection is going to have the configuration where the voltage starts to add up the more solar panels you hook up, but the amperage stays the same. And in the parallel configuration, the voltage stays the same, but the amperage starts to add up as you start hooking up more and more solar panels. And most of these inverters here have a max voltage and a minimum voltage, and they'll have like a maximum amperage. I really never see these have like a minimum amperage. It's usually just like a max amperage. And so that's the kind of the main point that you want to get from solar panels is you want to understand the voltage and the amperage and how that starts to add up or multiply when you start hooking them up in series or parallel. Because in the next video that I do, we'll go over the inverter and we'll go over exactly what the kind of PV input specifications are. Like how many, what's the range of voltage that you need in order for this inverter to turn on, and what's the maximum amount of voltage that this inverter can handle before it starts to damage the components inside. And so when you look at a spec sheet, it's going to tell you the ranges, and you're going to be able to kind of calculate those ranges based off of your solar panel kind of specification sheet. And that's these kind of figures that we went over. And so I'll kind of end this video here. On the next video, we'll kind of go over the inverter and we'll take this information that we learned here and we'll see if we can apply it to the all-in-one inverter. All right, hopefully that made some sense. If there's a part that didn't make sense, just let me know. I'll try and kind of give a different analogy or make another explanation, something that will make sense. All right, I'll catch you guys on the next one.